Hello everyone, welcome back to Path for Cloud. So today we will see how authentication works in our Kubernetes, right? Because I am just wondering, we just set up our cluster using a kubeadm setup, and then we installed a kubectl command, and we can directly run that k8s nodes, right? And it is giving me the output or whatever I am just trying to list, create, delete. It is simply just allowing me to do everything. But at the back end, how exactly it is being done? What is happening, right? How a Kubernetes allowing me to do all this? Whether if I switch my user to different user, in that case also I will be able to do that or not. Here K is nothing. I just set an alias to to type easily. So yeah, or if I just try to do something from outside to give some API call to my cluster to list my pod or something. So in that case also whether it will be allowing me or not. If it is allowing me, what I need to do in case of it is working, right? So that all these things we need to discuss in today's video. Okay, so let's start. First of all, we need to understand that what is TLS certificate, right? See, TLS certificate is something which you can uh, use to encrypt your communication. Inside Kubernetes, we have learned there are a lot of components in our Kubernetes architecture video where a kube API server is the main point of contact whenever being a user or admin or developer, if I want to talk to my cluster, I need to talk to the kube API server. If my worker node talk to a master node, they're also using a kubelet, they will talk to kube API server, right? And all these communications are encrypted, right? But how these TLS certificates are being generated, who is responsible to do that, right? And where they are stored. So that all these things we will gonna explore in our video today. Okay. So see, when you do, there are two things. If I just talk about the RBAC, RBAC is nothing that role-based access control. There are two things under this. One is the authentication, and second thing is authorization. What all these things? See, authentication is something where you just prove your identity. Okay, I am the same guy who I am trying to present myself, right? If that is allowed, then wherever you are trying to reach, that particular road blocker or maybe the checker will allow you, and you can go inside that particular thing, right? If in terms of in the normal layman analogy, if I talk, authentication is something, let's say if you are working in your company, right? They have given you a kind of what? They have given you a ID card, right? Showing that ID card at the gate, guard will allow, or maybe if any kind of the gate is there, you just punch that and you will be get inside your office premises. That is the authentication, right? But now authorization is like what power you are carrying with yourself. Whether you are a admin who can go inside any of the room, whether it's a data storage, whether it's a HR, whether it's a finance, or if you are just simply to a particular your ODC where you are working. So that is something the authorization. Maybe it was not a good example, but just to give you a understanding what authentication. Authentication is something just to get in. Authorization is what you can do when you get inside, right? So in terms of Kubernetes, if I talk about, so in authentication, when you trying to talk to the Kubernetes cluster, somehow you need to authenticate, and that somehow is TLS certificate in the case of Kubernetes. Whether you have a local user, whether you have a AD user, there are some additional configuration which you need to do in the Kube API so that it can authenticate, get that particular user, okay, that user is real, or whether it's a service account. Once you get in, what privilege you are owning, whether you can create any resources or a particular resource, that all these things we will do, how we can do it, right? So there are three things. One is the user, then a group, and there is something called service account. So the first two things are obviously a real human, right? Maybe you are administrator, cluster admin, or maybe you are just a storage admin, or maybe you are just a certificate approval administrator, which you do. Or maybe if you are a team of the that particular roles, maybe cluster admin, storage admin, then what you can do, you can assign all the users on that particular group, and you can create a TLS certificate, and then you can allow the authentication. Yes, you can create a TLS certificate. We will see in today's video. Service account is nothing. Service account is kind of entity which allow a talking between a tools two tools, or maybe service to service. Let's say if you need a requirement to integrate a third party tool towards your Kubernetes cluster, maybe you are sending a logs to some other third party tools, maybe Prometheus or Grafana, where you are just throwing all the logs and you want to, but how that tool will get authenticated and get all these logs and get displayed on their dashboard. So that's where the service account comes. There are two things now. Users and group can authenticate using certificate and key. Whereas service account cannot do these things, authentication cannot done with the help of certificate and key. For the service account, we have to create a token. For user and group, you have to be certificate and key. This is the part of the authentication, right? We will see how you can create a authenticate token for the service account, and the certificate and the key for a user certificate. So the process is, let's say we will do what we will do, we will create one local account, and for that account we will gonna create a key. Then we will gonna create a CSR, which is nothing. A CSR is a certificate signing request, and that request we will take to the Kubernetes certificate admin, which will approve it. Approve will, in the sense, it will gonna sign this certificate with the Kubernetes as a CA authority, right? Who can issue the certificate, and then it will give it back to the certificate. So using this key and certificate, we will allow that user to authenticate against our cluster. That is the thing we need to do. Whereas token you can create. There are two types of token. One is the static, and the another one is the dynamic token. Static is something that one time you will gonna create and you will use that token forever, until unless whenever that service account exists, right? This is something that you can bind it inside the secret, and that token will be always there, and you can bind that secret inside your service account, and you can use that token. Whereas dynamic token is a kind of where a TTL is set by default is 1 hour, like the token will be valid only for upcoming 1 hour. You can change that duration, you can change that validity from 1 hour to maybe 6 hours, 7 hours, or max up to 1 year. You can set it, right? Minimum 10 minutes and maximum is 1 year. Why? Because let's say you don't want, because with this we have a very less risk in terms of security, right? Because if anyone get this token and they can authenticate, if let's say your service account will have a kind of good privilege, and if anyone got your dynamic token, so probably can do some nasty in your cluster, and that you don't want. So that's why if you are running some kind of pipeline or something, and let's say that pipeline runs only for 2 hours, so it would be good like just for a 3 hours or 2 hour, like that you can create the token and you can assign that. So in the lifetime of that pipeline, this token will gonna use, and after that it will gonna automatically expire. So that's what that the authentication is and the authorization. So we will see this, but first let's come to our first question. Like after a cluster is being set up, now you are just simply running k get node, because here you can raise a question. Now you are saying we need a TLS certificate to authenticate authentication ourselves, and then we need some rules to do some actions, right? Because TLS certificate is authentication, right? So by default, when you do this kubectl, what kubectl do is kubectl will look into a user's home directory, and then there is a file directory called .cube, and under this we have file called config. So if you see this file, so you can see there are a lot of keys and API server address, some users mentioned. So let's try to understand what all these. So this is again a kind of manifest file where you will put all these details. So what all these detail is you need to just put the API version. You can put an n number of clusters. You can give n number of context, and you can give n number of users. Why n number? Because you don't want to manage a multiple config file, right? Let's say if you being an administrator, if you are managing a multiple cluster, maybe one is production cluster, another one is, let's say, a development cluster, or maybe if your cluster is running somewhere in the cloud, right? And that you want to manage from your laptop. So how you can do that? This is the way you can do that. So I will show you how you can create this config file for a particular user, from where you will get all these certificates and the certificate data for the user and the client. So let's try to understand first. So the first part it says is cluster. So under this, you can give its array, right? N number of cluster you can give. You can just define the certificate authority data. This is the main certificate of your Kubernetes cluster. And how it is being generated when you do a kube ADM setup cluster installation, right? Automatically this TLS certificate will gonna create. Now you will say these TLS certificates are needs to be signed by some CA authority, right? No, you can self-sign as well. And in this case, Kubernetes uh, like signing these certificate by itself. I will show you how you can find all these things. And this is the certificate you can just put, and it is not in the normal direct text. It is in the base 64 encoded format, right? You can decode it and you can match that particular certificate. Then you need to define a server address, which is nothing your server where you have your Kube API server exposed. Since we are running in locally, so our server is exposed on this IP and on this port. If just for your understanding, if you want to give a name to that particular cluster, it is just you can give any name, right? Like the production cluster, KubeADM cluster, or maybe Azure cluster, like that you can give, right? It's not something that which is binded somewhere inside the DNS or maybe certificate. No, it is just for your understanding inside this file if you are managing multiple cluster in this. So you can just name to that particular this array that okay, this certificate is for this my Kubernetes cluster, right? This is the by default file, so I haven't created anything, but this is the name by default. KubeADM given name to my cluster is Kubernetes. Then you have a section called users. Now you can define a multiple users here. Again, I am defining a user. Which user? I am defining a Kubernetes admin. And under this user, you need to define a one is the certificate client certificate data, which is nothing. The certificate which I talk here, right? Like you can create a key, you can create a CSR, and then you can pass these information to your Kubernetes certificate administrator, who gonna sign that particular CSR with the main certificate of your Kubernetes, and then revert this certificate. So this is a signed certificate, right? Again, it is a base encoded 64, and this is the key, which key we have used to get this certificate signed, and the CSR key. So these things you can define. If you don't want to put this data in the base 64 encoded format, so what you can do, you can directly give the path of that certificate file, that your user certificate file, and the user key. So in that case, you just need to remove this hyphen data from here. Only for that, the property is certificate authority, and you can define the path of your certificate file. And for user part, it is a client certificate and it is a client key. You can remove the hyphen data from here as well if you want to wish to give you a certificate file. But if you don't want to expose where your file is sitting, then you can put it in base. By default, it is in base 64 encoded. The third section is context. Context is nothing like where you are matching thing. Like this is the user you have defined. This is the Kubernetes cluster you have defined. Now, which user can talk to which certificate or cluster, right? So that part we are defining under the context. So you can see here the cluster is Kubernetes. User I am giving this. So here I am just giving a name called Kubernetes. And here I am giving a username is Kubernetes admin. So you can bind this like on this cluster, this user can authenticate this way. And current context is nothing that is the default behavior of this file. Let's say if you have a multiple cluster inside this file, right? And you don't want to specify that particular thing, that what you can do is you can set this as a default cluster. Like whenever you are running kubectl get nodes, so it knows to which cluster I need to authenticate using what user. That's what this config file is, right? So this is how we are getting authentication done. Now let's come to the authorization, how the authorization works, right? So for the authorization, we have two things. One is you need to define the role, and the other thing you need to define the role binding. What are all these? Role is nothing, role is just list of actions, and binding, as the name suggests, right? Role binding, whatever the role you have created, you are binding that particular role with what user, group, or maybe the service account. SA is nothing, it's just a short form for the service account. So this role you need to define what roles you can do, and you can bind that particular role to particular user, group, or maybe the service account. Based on that defined role, if that particular user is able to authenticate, then it can perform all these actions. All right. So here now you will see how will I come to know that, okay, this being a Kubernetes admin, what roles is defined to me. So there are two ways. Either you can create that like if that user is having in that AD or maybe LDAP. Once that the information get, they can authenticate, right? And then you can define that particular role and authorize or maybe role binding. Or what you can do is you can create some role, and that role you can embed it in your certificate. Right, that's possible. So by default, you don't need to do that. You can create a dedicated certificate for a particular role, and once that is done, so using that certificate, a particular person will get authenticate, and wherever you are binding that particular role, that will perform this. So we will see in action where we'll gonna create a local account, and then we'll create some role for that, and then we'll bind that role to a user, and then we'll create a dedicated config file for that user, and we'll see whether we will be able to authenticate. If yes, then we'll see that whether we are able to perform all those actions or not. All right. So now let me clear my screen. There is a directory called Kubernetes PKI. Here you can see we have a lot of certificates, lot of key, right? Some are dedicated to etcd. If you just see this etcd, so you have some etcd. So what is happening is whenever your kubeadm is setting up your cluster, right? It gonna create a main certificate and main key. This is the CA certificate, and this is the certificate. Whatever the other certificate you are seeing here, .crt or .key, everything is get signed using this CA cert, right? So that's how here the issuer is the Kubernetes itself. It is getting signed all these certificate behind the scene. For the etcd, it has created a dedicated certificate, and all these health client or the peer certificate or the server certificate or key, all these certificates and keys are getting signed from using this certificate. right? So this is something that you can understand how you can create a certificate and the key, right? If you need more information on how TLS exactly work, how we can create a key and we can bind all these things using that particular, how exactly we can make it available inside our browser, and then we'll create a real certificate for our website in the then let me know in the comment box. I will create a dedicated video for this. But now we will focus only on the our Kubernetes TLS certificate, right? So there is a command, this one. If I just simply run this, so what it is doing is this command is giving me the text output of the certificate file. How here you can see the issuer is itself a Kubernetes, which is doing it, and this is the validity. You can see by default it is getting, and these are the keys. What are the key, like how many, what is the size of that key, that bit key we are using in 2048. These are some additional, maybe if you have some additional DNS name or alternative name you have binded to that particular, that you can give it here. And these are the signature key, right? So this is the main certificate. If the same thing, if I'll do for the something called API kubelet, right? So here you will see this certificate is again issued by the Kubernetes. This is the validity. But here you have something called object, right? Like what is this kube ADM cluster admin? And you have some additional the same stuff. If you have some additional name to that particular certificate, then you can bind it here, the keys and everything. But right now I am more interested into this part, which is this one. So remember, just a couple of minutes before I mentioned that you can bind this role, right? You can embedded this role inside that particular certificate. So in this case, what is happening is when a certificate was created, this one API server kubelet client certificate was created using the CA cert. So what happened is they have embedded this role. Yes, this is the role, and this role is having some list of actions, and it has binded to what? It has binded to the Kubernetes admin cluster, which is nothing, which is just a system admin masters, right? If I take you to the file called this, so here you can see, right? We have some internal defined groups already, which is defined in the Kubernetes. By default, Kubernetes ships with a handful and special reserved group just to start with the system. So you can see we have system masters, and what system masters can do, full cluster admin rights, right? They are automatically added when you bootstrap a cluster with kube ADM. So this group is automatically created, and there are multiple groups. I will uh, push this file to repo. You can explore, you can see that system node. If you have that system nodes, then what you can do, you can authenticate against each node. Like you can talk to a node, you can add the new node, you can delete that node. So all that stuff you can do with this group. You have the service account, all the service account are part of this group. So this is a kind of pre-built groups which automatically there. But you can create your own user service account, and you can bind that role and role binding to those, right? So let's come to our cluster. And if I, yeah, there is one more thing. When I say role and role binding, right? Let me show you something. KAPI resources, and if I just grep for role, so you can see we have something called cluster roles and we have something called roles. If you just look at this column is for the namespace. Cluster roles are not namespaced object. Means whenever you are creating a role, let's say if you are giving a permission to list all the pod, right? Then it is not a namespace. Whosoever is assigned this cluster role, which has a list of action, is just to list the pod. He or she can list all the pod irrespective of all namespace. That's what that cluster role or cluster role binding is. Means they have access across all cluster, right? Whereas role binding and roles are a namespaced object. If you want to do restrict a particular namespace or something, then you need to bind that role inside that particular namespace. Then only it will be, and it will be applicable only to that particular namespace only. It cannot go outside of that namespace, right? So there are two things. So if I just list k get roles, you will, okay, I need to specify the namespace. So for default namespace, we don't have any role, but for cube system, you can see we have few roles assigned. And there is one of the role which I was talking about that is not listed here. Why? Because if you are using now kubectl, right, then there is no use. You can see that I can list the node or the pods or the roles from different file system, not only from the default namespace, from a different. That means whatever the roles as of now I have binded, that is a cluster role, not the namespace role. All right. So instead of getting a roles, what I need to do is I need to uh, run cluster role hyphen n cube system, because that's what that I have this cluster role defined. Okay, there are hues, but I am more interested in the this one, cluster admin. So this is the role which is assigned or maybe embedded inside my certificate, right? Let's see what this role can do. Again, if you want to do more information of any of the object, what you can do, you can just simply describe that object. All right, so I am describing a cluster role called cluster admin inside a cube system namespace. So you can see what all actions I have assigned to this cluster admin. This cluster admin can do anything with any of the resources, and verbs are nothing. Verbs are just a kind of action like get, delete, create, watch. All these are verbs. So here you can see I am giving a star. I'm not me maybe, but whatever that it has been designed is with the every verb, like whatever the action is associated with that particular resource, everything it can do. So this role is a very huge, high level role with all privilege. It can do anything inside the cluster. All right. Now I need to see where this role is binded. So for that, if you remember, we have discussed role is nothing. Role is just the list of action. But in order to get this done, you need to bind this role to a user, group, or maybe a service account. Obviously, so let's see where this role is get binded. So I just say cluster role binding, and I am interested in the cube system namespace, and let's just grep for cluster admin. Okay, what is missing? There was a additional space. So here you can see we have a two cluster role binding. Yes, you can bind that particular role to many users or group. So here you can see the role is common cluster admin, but it has binded to a two cluster role binding object. One is the cluster admin and another one is the kubeadm cluster admins, right? So I am interested in this. Again, let's describe this cluster role binding, this one, and it will be in this. Okay, there was a typo. It's not describe, it should be describe. Sorry about that. So here you can see this cluster role we have seen, it has a full privilege. Now, who can assign? You can the system masters, right? So this is the group, and it group what can do? You can see this is the system group which is already inbuilt group with full cluster admin rights. Why? Because it has binded to a role called cluster admin which has a full privilege, right? That's how that you can find, and you can create your own role as well whenever you need all these. Okay, so these are the cluster roles, and these are the, if you just want to see k get cluster role binding inside the cube system. Cluster role binding. So you can see we have many cluster role already because it is for the internal purpose. If you want to get more information, maybe you can just go and explore that. Like you can describe and you can find out, okay, which cluster role admin can do what. If you see this k get node, where is the describe command? Here it is. I just want to show you this. So here you can see this is allowed to this system bootstrap cube ADM default node token. If I just show you this bootstrapper, so they can bootstrap token used by the kubelet bootstrap token. That means that whenever you are setting your cluster, right, how a node can join your cluster. That's what it is being defined by this group. And how they can do that, you can explore this cluster role. Let's quickly describe. K describe cluster role, this cluster role, and it is inside the this namespace. Okay, again describe CRI. So you can see it can get the nodes. If you have this privilege, you can get the nodes. That's how that you can define or you can explore all these cluster roles and binding. All right. So this is the way that the TLS certificate is required to authenticate to the cluster, and to authorize what you need to do. You need to have a role and you need to bind that role to a particular user and group. All right. So this is how these all are done. Okay, what I will do is I will take a pause from today for this. In the next video, I will show you how you can create a dedicated user, and using that user, how you can create a certificate, get it signed from that Kubernetes, and then using that certificate and key, how we can authenticate. And then we're gonna define some role for that particular user, and we can bind that role to user, and we'll try to get that thing done. All right, so that's what the agenda for the next video. All right, so that was about the TLS certificate, where I have tried to explain more in detail, like how exactly the RBAC works in the authentication or maybe the authorization, and then you can do all these things. All right. So again, if you find this content is helpful, which maybe helped you to understand, like by default, when you just run a kget or maybe whatever the command I am just running now, how exactly it is talking to my Kubernetes cluster and getting all these things for me to read, right? So that's what it's, there is no magic. It is just the logic which it is using behind the scene is TLS based certificate, because by default it is creating for us one user kube config file, right? And if you need to create that file for another user, that we will see in the next video. All right, so that's it from the day, I believe, and we'll see next what we can do with our certificate and the keys. All right. Thank you guys. I will meet you in the next video. Bye bye.